So in th- so in this video, we are going to look at balancing chemical equations. Let's dive right into it. Let's start with this combustion reaction. Benzene C6H6 reacting with oxygen gas to give us carbon dioxide and water. Now, anytime we are balancing chemical reactions, our primary goal is to make sure that the number of atoms on the left-hand side and then the right-hand side are all the same. Now let's start by balancing the carbon atoms. So we see that there are 6 carbon atoms on the left, but only one on the right. 1 carbon atom over here and 6 carbon atoms over here. So what we are going to do is we will put 6 in front of the CO2. Then next, we are going to balance the hydrogen atoms. There are 6 hydrogen atoms on the left, but only 2 on the right. So what we are going to do is we will put 3 over here, so that when you multiply 3 and 2, you get 6. Now we see that we have 6 carbons on the left, 6 carbons on the right, 6 hydrogens on the left, 6 hydrogens on the right. Now we are left to balance the oxygen. Now we can see that for the number of oxygen atoms on the left, we have for the oxygen we have only 2 on the left, and on the right we have 15. So this is what we do. So 15 divided by 2 gives us 15 on 2. So what we do is we put 15 on 2 in front of the oxygen over here. Now this is not an ideal practice. So what we do is that we multiply the entire expression, the entire equation, with the denominator, which is 2 over here. So that means on the left hand side we are going to have 2 C6H6 plus 15 O2 giving us 12 CO2 plus 6 H2O. Now let's consider this other example. We have iron reacting with oxygen to give us iron 2,3 oxide or magnetite. Now let's see how we can balance this chemical equation. So first of all, let's start by balancing the iron. So we can see that we have 3 atoms of iron on the right hand side. So what we do is that we put 3 over here. So the ions are balanced now. We have 3 atoms of iron on the right hand side, 3 atoms of iron on the left hand side. Now it's left with the oxygen. For the oxygen, we have 4 atoms of oxygen on the right hand side, but 2 on the left hand side. So 4 divided by 2 gives us 2. So what we are going to do is that we are going to put 2 in front of the O2 to balance the reaction. Now the balance equation becomes 3Fe plus 2O2 giving us Fe3O4. Now the next example we look at is the combustion of aniline. Aniline has the formula C6H5NH2. Now this is reacting with oxygen to give us carbon dioxide and then water and then nitrogen gas. Now let's balance the equation. So first of all, I'm going to start with the nitrogen over here. Nitrogen has 2 atoms on the right hand side. So what I'm going to do is that it has 2 atoms on the right hand side and 1 atom on the left. So I'm going to put 2 in front of the aniline over here. So this means that nitrogen over here is 2 and over here it is 1 times 2, which is 2. So nitrogen is 2 2. Now let's go to the next one, which is carbon. Carbon on the left hand side becomes 12 over here. So 12 1. So what do I do to the carbon over here? I multiply this one also by 12. Now that means I have 12 12 now. Now the next atom I balance is hydrogen. Now hydrogen over here we have 2 multiplying 5, which is 10, plus 2 multiplying 2, which is 4. So that gives us a total of 14. So a total of 14 on the left and a total of 2 on the right. So I need a factor to put on the right. I'm just going to divide. So 14 divided by 2 gives me 7. So I'm going to put 7 in front of the water molecule over there. So that means the hydrogen is balanced now 14 14. Now the only atom that is not balanced currently is oxygen. Now oxygen is 2 over here. 2. So oxygen is 2 on the left, but on the right hand side it is 12 by 2, which is 24, plus 7 by 1. So all that is 31. So the total number of oxygen atoms on the right is 31. So 31 on 2 is just 31 on 2. So I'm going to put 31 on 2 in front of the oxygen over here. So 31 on 2. Now ideally that's not the right way of doing it. So what we are going to do is we are going to rewrite the entire equation. We are going to rewrite the entire equation. Now this is going, so rewriting the entire equation, we have to multiply through with the denominator over here. So we are going to have 4 moles of aniline, so it's 4C6H5NH2 reacting with 31 moles of oxygen gas to give us 24 moles of carbon dioxide plus 14 H2O plus 2N2. We use the 2 as a denominator over here to multiply throughout the entire equation.